In this video, we will discuss rule number 6 for particular integral. We have already done 5 rules to calculate the particular integral. These rules were applicable if your capital X is of the type e power ax, where we use rule number 1. Similarly, if your x is of the type sin ax or cos ax, we use rule number 2. If your capital X is of the type small x power m is some positive integer and x is independent variable. If your capital X is of this type, we used to apply rule number 3. And if your capital X is of the type e power ax into some function of x, here v is function of x, small x, then we use rule number 4. If you are having capital X as x into some function of independent variable small x, then we use rule number 5, right? These rules we have already covered in the previous videos. But let's say if this capital X is not of these types, if you are having some other function, then what we will do, here we can apply this rule number 6. But the only requirement for this rule is that you must have the linear factor here. Okay, let's understand this concept along with one example. So if you are having d minus a into some function of x, then what we need to do, first thing is just to observe the value of a. Once you are done with the a, then you can apply this formula. So we'll take that a here, e power ax, and then we'll integrate capital X. Capital X is the given function into e power minus of ax. And then after integrating, you'll get the final answer for the particular integral. And we will not going to add any of the arbitrary constant because we are calculating the particular integral, and in particular integral arbitrary constants are not involved. Okay, now this is our example which we are going to solve. So first thing is, what is your capital X here? This is our capital X here, right? Now this is not of the form e power ax or sin ax or cos ax or x power m or something. So we have not any of the rule which is applicable for such type of functions. So that means here we need to follow this rule number 6. But before that, let's calculate complementary solution. Okay, so for that we need to write the symbolic form first. So what is the symbolic form? D square y plus 3dy plus 2y equals to e power x. Here x is our independent variable, the small x is the independent variable and y is dependent variable, right? And here capital D is what? This is the derivative with respect to independent variable small x. Now next, can we write this as d square plus 3d plus 2y equal to e power x. Now next is auxiliary equation. Auxiliary equation is f of d equals to 0. Now what is my f of d? This is my f of d. Okay, this is my f of d. So my auxiliary equation will be d square plus 3d plus 2 equal to 0. Next is to find the roots of auxiliary equation. So what are the roots? So if I split this into the linear factor, this will be d plus 2 and d plus 1 equal to 0. So d will be minus 2 and minus 1. So these roots are real and distinct. For real and distinct rule, how we used to write the solution, complementary solution. So this is real and distinct root. So first constant e power first root minus 2 into independent variable x plus second constant, that is C2 e power second root into independent variable x. So this is a complementary solution. But because this is non-homogeneous differential equation, as we are having capital X is equals to e power x, we have to calculate particular integral also. Now how we will get the particular integral? So particular integral used to be 1 over f of d capital X. Now what is my f of d? That is d square plus 3d plus 2 and e power x, right? Now first thing is we have to split this into the linear factors. Okay, so for this function, first thing is to write the linear factor, that are d plus 2, d plus 1, e power x. Now here we need to apply rule number 6. And what was that rule? So that rule was this, right? So first of all, we'll apply this rule over this thing. Okay, we'll keep 1 over d plus 2 as such, and we will apply the rule over 1 over d plus 1 e power x. Now if I observe, what is my a? So here, can I write this d plus 1 as 1 over d minus minus of 1 e power x? Right? So my a is minus 1. Now just substitute this value here. Okay? So apply this rule. So according to the rule, what will we will get? Sorry, here we have 2. So here your d plus 2 will be as such, and here apply the rule over this. So e power ax. What is my a? So my a is minus 1. This minus 1. Okay. So minus 1 into x integration. Integration capital X. What is my capital X? My capital X is e power x. So e power x into e power minus of ax. E power minus a. A was minus 1 x dx. Okay. So after simplification, we will get this thing. Now we have to integrate this part. Okay. For this part, what I'm going to do, let's assume this as I1. For a time being, let's assume this is I1. So I1 is equals to what? E power x dx. Okay. Now for this, put e power x equals to t. So this implies e power dx will be dt. After differentiating this thing with respect to x on both sides, we will get e power x dx will be dt, right? So this thing will be dt, this thing is t. So my I1 become e power t dt. What is the integration of e power t with respect to t? That remains e power t. And here we are not going to add any of the constant because we are calculating the particular integral. And what was your t? T was e power x. T was e power x. So just substitute this value. So you'll get this thing. So this is the value of this integral. Now back substitute this value here. Okay, back substitute this value here. So what we will get now? So after substituting the value, we will get this thing. Okay. Now here my updated capital X is this. Okay. So we are going to apply rule number 6 again. So what was my rule number 6? So this was my rule number 6. Okay. So we have to apply this again. So what is my A here? Can I write this D plus 2 as 1 over D minus minus of 2? Okay, e power minus x, e power x. Now what is my a? If I compare this thing with this, my a is minus 2 and my capital X is e power minus x, e power x. Now apply this rule. So this will be equals to e power ax. What is a now? Minus 2. So minus 2x integration capital X. Capital X, this capital X is what? E power this one, e power minus x, e power x, and e power minus of ax. My a is what? My a is minus 2. So minus of minus 2x dx. Now after simplification, we get this thing. Okay. So here we have e power 2x, here we have e power minus x. So base same, so power will be added. So what we will get? So this will be equals to e power minus 2x as such. Integration of these two terms will be combined. Okay, powers will be added. So what we are going to get? E power minus x plus 2x, and along with that this e power x as such. Okay, so here we'll get e power x dx. So what we will get? This will be e power minus 2x as such, and here this will be e power x, e power x dx, right? Now we have to solve this integral. So let's say this is I2. So I2 is e power x, e power x dx. All right. Now again put e power x equals to z, let's say. So after differentiating on both sides with respect to x, what we will get? E power x dx will be dt, sorry, dz. Okay. So e power x and this dx, this thing will be dz. Okay, so here I2 become e power x becomes z dz. So what is this? This is e power z. Integration of e power z with respect to z is e power z, and again we are not going to add any of the constant because we are calculating particular integral. So what was z? Back substitute the value of z. Z was e power x. So e power x here I2. Now back substitute this value here. Here, sorry. Back substitute this value here. Okay, this is the value of I1. So what is the final answer for particular integral? That is e power minus 2x. Okay, and what is the value of this integral? This integral come out as e power x. Okay, so this will be e power x. So this is the value of particular integral. Now what will be the complete solution? So complete solution is equals to dependent variable equals to complementary solution plus particular integral. We know what is our complementary solution, that was c1 e power minus 2x plus c2 e power minus x, and what is our particular integral? This is this one. Okay, so this is e power minus 2x e power x. So this is a final solution. With this we are done with all the 6 rules. Okay, after this we are going to discuss Cauchy differential equation in the next lecture. Thank you very much. This was all about this topic.